And welcome back. And what we're going to do is we're going to write some complex numbers into trigonometric form. And we have three different examples right here that we're going to go through. So we'll start with example number uno. All right. So this is number one. And the first thing we're going to do is I always like to draw out my complex number. And so what we have right here is we have this complex number of um, right here is going to tell us it's going to be square root of 3, which is going to be in a real plane. So here's 1 and 2. And then we're going to go -1 in our imaginary. So this is I, this is our real, if you remember from the past. And so what we have is right here is going to be -1, here's 2. And so we're going to graph this, and we know this is going to be 5 halves, 5 halves. So if we multiply this by 5 halves, um, we know that everything will be 5 halves much bigger. And so we have 5 square roots of 3 halves. And so that's going to be 2.5. And so we're going to have here, here, and here. And so that's going to go down there with our I. And then right here, the square root of 3, square root of 3 times 2.5. Square root of 3 times 2.5 is going to be roughly about 4.3-ish. And so if we go over here, 1, 2, 3, 4, a little bit right there. And so what we have is right there is our complex number of 5 halves square root of 3 minus I. Okay, and we can label that something label Z, and that's what we have there. Now, from here, we can do is we realize this is in the fourth quadrant, and we can kind of see what type of triangle this is going to be. Well, right here, since we have 5 halves, and we have this portion right there, we know that this angle is going to be 5 halves, is our radius right there. Okay. Oh, not actually, that's the radius. But what we have from here is going to be, this length is going to be 5 halves, square root of 3. This one's going to be just 5 halves, or -5 halves. And if you go right here, so we see that we have this triangle of, all right, square root of 3 and -1. And so what we need to do is we need to figure out what is this angle, and then what is this ratio. So we have 1 radical 3 and 2 ooh. So 1, which is -5 halves, square root of 3, which is 5 square root 2 square root of 3. And this one's going to be this length times 2. So actually, our radius right here, if you use Pythagorean theorem and whatnot, should equal negative, or actually equal 5. Should equal 5. That's the radius, so it'll be always positive. Okay, so what we know now is we're going to take this, and we're going to actually find out what this angle theta is. Well, knowing that we have 1 radical 3 and 2, this is actually a 30-degree angle. All right, opposite that. All right, and so this angle theta, if we go all the way around, is going to be 330 degrees. 330 degrees. So we can figure this out by knowing that we have a plus bi, if we recall from last time, is going to be r times this cosine of our angle plus the sine of our angle times I. And so right here, since we have this is right there, so it'd be 5 halves. All right, actually 5 right there. So going from here, in order to write this out, plug in all the values that we know that r is equal to 5. We know cosine. Cosine is going to be cosine of, all right, cosine of 330. So we have that right there. We know that sine is going to be sine of 330. And I guess sometimes we put the I, maybe not right there. Maybe we should put it in front, just so we don't get confused. All right, so we'll put the I right there. The sine of 330 degrees. And guess what? That is equivalent to Z, which is equivalent to this right here. And that's our trigonometric form. Find the angle, find our radius, and plug her in. Let's try another one. Okay, example number 2. Example number 2. Let's try that. Okay, so going down here, we have example number 2 is going to be 4i. All right. And in this 4i, we can once again draw this out. And what we realize is this can be 1, 2, 3, 4. And there is no horizontal, so we have this point right there. Well, once again, we have to figure out this is not really a triangle, but we have to figure out what is our r. R equals 4. We know that our angle is actually 90 degrees horizontal, so our angle right there is going to equal 90. Or if you want to put it in radians, you can go pi over 2. All right, radians. And so, in order to figure out this 4i, which equals, say, z, is actually going to be equivalent to 4 times the cosine of 90 degrees, which we know will be 0, plus I times the sine of 90 degrees, which we know is equal to 1. And so what we have is 4i as our answer. And this, my friends, is once again going to be our trigonometric form of this complex number. All right, well, we'll go one more while we got you here. And I'm going to go example number 3. Example number 3, we're going to take this one. I'm going to go down a little bit more. All right, so 3 minus I. Okay, so we'll go example number 3 is 3 minus I. And if we would graph this out again, okay, this is our real, this is our imaginary. And what we have is 3, 1, 2, 3. And then we have negative I. Negative I goes down right there. Negative I. All right. And so we have this point right there. Okay. Well, once again, I'm going to draw out a little triangle. So we have this is 3. This is going to be 1. We're in the 4th quadrant. And we got to figure out this value. Now, this angle is not a real nice one. 3, 1, 3. Well, square root of 3 helps us out, but that's not good. All right, so let's first figure out our radius. Okay, radius right there, our r value. That's going to be the square root of 3 squared plus 1 squared, which is going to be the square root of 10. Okay, so we found our r. So this is going to equal the square root of 10 times the the cosine of the angle plus I sine of the angle. Question is, what is the angle? Now, if you recall in my previous videos, how do we figure this out? Well, to figure out this angle, we're going to find that reference angle first. And we're going to take, and to find the angle, is we're going to take the inverse tangent. Inverse tangent in this case is going to be of -1, opposite over, all right, adjacent, which is 3. That's going to give us our angle. Now, you can put this in your calculator. You can put this in degrees. Maybe that would help out. So if you make sure your motor's in degrees, and you take the arctangent of -1 divided by 3, or inverse tangent of -1 divided by 3. And what we get then is this angle right here, approximately -18.435. All right, now that makes sense because tangent is in the 1st or 3rd quadrant when you take the arctangent or inverse tangent. And so actually, if you put that in there, that would actually work out. Or what you can do is actually take this and make this into a nicer angle, which is from 0 to 360, by taking 360, all right, minus 18.435, which will also give you an answer of 341.565 degrees. So if we continue here, we can say that this is actually the square root of 10 times the cosine now of 341.565 degrees plus I sine of 341.565 degrees. And that, my friends, will give you this complex number. And that's trigonometric form. All right, cool. Well, there we have it. How do you find complex numbers? Well, first off, you need to find the r value. All right, draw it out. Find out what that radius is, what that length of that one triangle is. That's going to be your magnitude. All right, if you have vectors here, but we're going to tell you my magnitude there. We have our cosine of the angle plus I sine of the angle. Find what the angle is by using inverse tangent. all right, from a triangle. Make sure you know what quadrant it is so you can figure out what proper angle it will be, and then you plug it in, and bada bing, bada boom, you get your answer. All right. Well, I hope this helps you out on how to convert complex numbers into trigonometric form of complex numbers, and we're gonna have one more video of just how to go the other way in just a little bit.